Without further ado, the moment you've all been waiting for, let us get into this chat with Josh. Josh, thank you for joining us and thank you for coming here to talk to me about what you've got going on. I think we had originally said, you've done a few talks / lectures on the evaluation store and why it's needed. So we're not going to just do that talk again. What we wanted to do today was you've had enough of that talk, I imagine. You've given
enough of that talk,
You've given it too much, and you now get to answer questions about it. So for anyone who doesn't know, I will also try and throw up a link to that. I've got a lot of links that I need to be putting up while you are talking, Josh. So go ahead and feel free to answer the first question with whatever background information you want. You can string it out as much as you want. Now, we should probably start with an idea of your background and how you came to be where you're at. What got you into tech even?
Sure. Yeah, I mean, I guess I can kind of go all the way back. When I was an undergrad, I was sort of, wanted to be a mathematician. That's like what I wanted to do with my life. And, was doing research over the summers, thought I was going to go, do a math Ph.D. somewhere. And then had this kind of crisis of confidence before my senior year where I realized, like, hang on a second, if I go down this path, then this is how I'm going to be spending my life. I'm going to be, staring at a whiteboard by myself, like working on problems that are really interesting, but fundamentally, like, don't actually make the world better in most cases. And, no one actually really cares that much about the answers to them. So ended up kind of doing a full 180, went into management consulting for a couple of years at McKinsey. Quickly realized that was really interesting, but an overcorrection, and ended up back in grad school at Berkeley. And when I went to Berkeley, I really, I knew I wanted to do something more useful with math, but I didn't really know what that was going to be. And my first semester, I was, shopping around a bunch of classes, and I stopped by this class on machine learning and robotics, stopped by Pieter Abbeel, and just really quickly got hooked on that subject. I was like, yeah, this is the thing to apply math to these days. So I ended up doing my PhD with Pieter, working on intersection of machine learning and robotics. So I did some reinforcement learning work, worked a little bit on generative models and their applications to robotic grasping. But really the bulk of my PhD work was on using simulated training data to solve real world problems with robots. So, the pragmatist side of my brain got really attracted to this problem because, everyone when I was at Berkeley was super, super excited about DeepRL, right? And it's this amazing research area, tons of promise. But the thing I couldn't wrap my head around was like, okay, well, all the simulated experiments that people are running, they're doing these incredible things. But if you read the paper, it's actually using hundreds of millions, if not more, training examples to make those algorithms work. And so I was like, how are we ever going to make this in the real world if we need hundreds of millions of labeled examples in order to train a model to do something interesting? And so I got really interested in the question of, like, can we actually do away with real world training data, if not entirely, then at least in part, by generating data from a physics simulator. And so that's what I did my PhD on. And throughout my PhD, I was really like splitting my time between Berkeley and OpenAI, and did a lot of this work there as well. And we were working on this dexterous robot hand, which is like this like $150,000 robot that, they make like 10 of them per year. And it's basically the size of my hand, more or less the same degrees of freedom as a human hand. And we were programming it to do like complicated real world manipulation tasks. And that work culminated in solving a Rubik's Cube in the hand. And how this connects to sort of how I got interested in machine learning ops and machine learning infrastructure and tooling is that a couple of years into my time at OpenAI, OpenAI was going through this interesting transition, right? Where when I first joined, it was kind of like half of Peter's lab was there. It was basically just an extension of Berkeley, a lot of academics, very academic feel, lots of kind of loosely connected projects. And over time, as the organization evolved, they figured out that they, in order to sort of fulfill their promise, they needed to figure out how to become more than that in some sense. And so we were figuring out how to like work together on bigger teams with, bigger budgets, more compute, more of a balance between researchers and engineers instead of just mostly being research driven. And there were all these like growing pains that we had to go through in order to make that work. And it was stuff that seemed like it should be, super simple and well understood, right? Like, how do you actually manage a team that has both researchers and engineers on it? Like those folks kind of have different goals, their work moves at different paces, but also really, really basic stuff like how do you even write good tests for machine learning code? Seems like a really simple question, but it's actually not that clear. And so as this was happening, I've been really interested in this question of like, how do we, going back to the question I was focusing on for my PhD, like, how do we actually take this amazing technology that we're working on and make it work in the real world? And so I was swapping notes with Pieter and one of our other friends, Sergey Karyev, who was running this company called Gradescope at the time. And we realized that like everyone in the machine learning world who was actually able to make this stuff work in production had to reinvent the wheel on all these things. And they'd had to learn all these lessons from scratch, really, because no machine learning class was teaching you how to monitor your models or how to deploy them. And we thought it would just be, good for the field if we kind of wrote down everything that we had learned about those things and everything that our friends had learned about them. And so we created this course called Full Stack Deep Learning. And we kind of ran that as a boot camp for a couple of years. We would bring folks out to Berkeley a couple times a year, practitioners mostly, and teach them like, about like scoping projects and troubleshooting models and testing and debugging and monitoring and kind of all the stuff that you don't learn in like a typical machine learning class. Fast forward to, let's say a little over a year ago, I was wrapping up my PhD, or I just wrapped up my PhD. I was wrapping up my time at OpenAI. And we put the course online, and it sort of started to take off a little bit in popularity in a way that at least I wasn't really expecting. It was kind of just this thing that we had done on the side for a while. Put a lot of effort into, but I had no idea whether people would really care about it. And it kind of started to take off in popularity. And so one of the first things I did was I spent some time with that community. We had like 500 or so people go through in person at that point, and just trying to understand like, hang on a second, what's going on here? Why do people care about this all of a sudden, right? And that was kind of the rabbit hole that led to getting sort of really full-time involved in this space and eventually starting a company.
I love it. The perfect link too, by the way. You gave me just enough time to...
You got all your links in? Okay, good.
I was able to share every link that was needed. I also realized you people were the ones behind the Rubik's Cube.
Yep.
Do you know Sasha Lucioni?
No.
She works at whatever. I read a paper on hers and she was calling you out. We don't need to get into it, but she was like, it's great. It's an amazing feat, but how much compute power and how much of this is needed to do this task? And are we thinking about the planet when it wasn't specifically like, she was using you as an example, but she was talking about like the research and kind of what you said, like, do we need all of this compute? Do we need all of this? Is it really necessary? And especially when we're looking at
I think I had sort
environmental things.
Yeah, for sure. It's an important question. I think so I worked on precursors to that project when the actual Rubik's Cube project was going on. I was doing some other research to wrap up my PhD, but so I feel like I can talk honestly about it. I think
nice.
It is an amazing feat, right? Like it's a pretty incredible demonstration of what's possible to do with deep reinforcement learning, if given access to infinite data, infinite compute, and $150,000 robot. And so in some ways, that's exactly what research is meant to do, right? It's meant to show you what's actually possible,
the possibilities
to solve. But in other ways, it's actually a perfect example of what I think is kind of a big failure mode in the machine learning community over the last, let's say, 7 or 8 years since the deep learning hype started to take off, which is there's a ton of focus on like making things work, making really, really cool demos, right? And so, the not so secret, like kind of caveat behind all of the Rubik's Cube work is that it, even with all that compute and all that stuff and all of the like person years of effort that went into that research, it actually only works in a very, very controlled setting in a lab with like lighting that's sort of been set up the way that you want it to be set up. And even then it only succeeds like something like 20% of the time. So, which is not to say it's not, I think it's still an impressive achievement, but I think it also just goes to show like how big the delta is between, what some companies are doing to be able to talk about how exciting machine learning is and what's actually working in the real world. And I think that's one of the things I think is starting to change. And I think the MLOps world is maybe part of that. But yeah, that's a trend I'm excited about is people focusing more on the impact of their models.
Yes. And I realized after or about midway through that question that my second question was basically calling you out. So I did not mean any bad blood by that.
It's all good.
And I appreciate the composure that you have in answering this honestly and really showing that, it is exactly what research is for. But yeah, maybe we can think through it a bit more and realize that there's more than just shiny demos. And so that's from what I think and what I know of full stack deep learning is that you're really trying to do that, like have people show that there is so much more to this than just the building a model and the statistics side. And so
100%. And I think, to be honest, like our class only really scratches the surface of that. It's meant to be an introduction to that subject for people and to bring folks in who have maybe an engineering background but haven't done a ton of ML, or have done a lot of ML but haven't done a lot of engineering, and to kind of give them one path down that process of productionizing a model, and then also kind of illuminate the rest of the paths that are available. And it's such a deep subject. We can't, we don't claim to be comprehensive, but hopefully it's at least like a way to see what some of the options are.
Totally. There's not enough time in the world to be fully comprehensive on all of these different subjects and to go down deep for each one of them. It's incredible how broad it is.
Yeah.
And so let's talk a bit about what you mentioned was a really difficult piece in machine learning, and that was testing. Can we go into that a little bit, and maybe you can explain some of your insights that you've seen on how you can do testing well in machine learning and how you can totally mess it up?
Yeah, for sure. I think, the fundamentally, I think the challenging thing about testing machine learning models is that it's, it's inherently statistical, right? So if you're trying to test the functionality of your machine learning model, it's really not enough to just like run that model once on a big data set and get a score out of it, which is the way that most people think about testing machine learning models. And the reason for that is that you don't actually understand the contours of that performance profile. And that starts to become a problem when you deploy models in the real world, because all of a sudden you start to run into like these failure modes that you weren't really expecting, and people are like, oh, data drift maybe. And that's one cause of those types of failures. But another big one is that you just, you didn't really understand what the limits of your model were before you deployed it. And I think that there's a bunch of ways that this rears its ugly head. I think edge cases are a big one, right? When you think about like what a lot of the focus of the self-driving car community is, it's like, how do we deal with these long tail events? I think Bias and fairness are another big one. I don't think testing is the solution to bias and fairness. I don't actually think there is a solution, at least yet, but it's at least, testing your models more comprehensively is at least one way that you can try to minimize the risk and the impact that those things have. But yeah, I think when I think of testing, like the way I think that companies should approach it is, if you look at like what say like a Tesla does, it's you have a bunch of metrics that you care about, right? So not just your accuracy, but also all these other metrics that give you some information about the health of your model. And then you have a bunch of data sets that you evaluate those metrics on. And those data sets are, it's like your overall evaluation set, but then you also have a bunch of like unit test data sets that can help you evaluate your model's capability on certain edge cases that are a problem for your model, edge cases where you want to make very, very sure that your model's performance doesn't degrade, edge cases that have maybe given a previous version of the model trouble. And then on top of that, you want to also like be able to facet your data or like slice your data according to different categories that you want to like be able to compare model performance along. So, like types of users that you don't want your model to be biased against, for example. So it's, metrics, data sets, and slices. And then at the end of that, you get a big report that shows like all of your slices across all of your data sets across all the slices of those data sets that you care about. And that's really like at a very high level, the way I think that companies should think about testing machine learning models. Now, that being said, there's like a lot of like kind of rough corners around that where it's just actually not very clear yet what the right way is to go about constructing those data sets or picking the slices or picking the metrics or even determining whether model regressing against one of the metrics is significant or not. So I think it's very much like, I think while the concept is pretty clear, there's a lot of like unanswered science there.
Yeah. So let's jump into this evaluation store, because that is something, it's a new term I know that is being coined, and I want to know what it is. We should probably start with what it is, and then we can get a little bit deeper into it.
Sure. Yeah. So the insight came from, I was thinking about like the life cycle of a machine learning model, right? And I think maybe actually just even taking a step back, I think the way, like to me, one of the fundamental differences between, machine learning research or even like production machine learning in the sense that like you're using your models to help do analytics, right? You're training a model that's going to produce some predictions and you're going to make, and then a human is going to like look at those predictions, use them to make decisions. The difference between that and what I think of as production machine learning, which maybe another term for it is like data products, right? So it's machine learning systems that are being used in the loop of a product or service that your company offers, whether it's internal or external facing, and is making decisions autonomously or semi-autonomously, but with kind of a tighter feedback loop than like an analytics-driven machine learning model. So that's kind of what I think of as production machine learning systems, these like data-driven products that have predictions in the loop. And I think there's a few fundamental things that make building those types of systems more challenging. One of them is that you often need to be able to run those models in real time. The data distribution that you're evaluating the model on is going to shift from under you, and it has, in many cases, it has a long tail. And so you can't really assume that like you can't make an IID assumption like you do in academic ML. And on top of that, like you need to be able to handle the fact that you don't always have a really tight feedback loop from the people that are making decisions based on those models' predictions. So those models need to be able to operate on their own and be able to alert you when things are going wrong. And so thinking about kind of the infrastructure that companies have right now for building these systems, there's one of the interesting things about the machine learning infrastructure world is that there's a lot. There's just a lot of stuff going on right now. And I think like a lot of people look at it and they're like, what's happening? Like, why are there so many tools in this space? And it's just so messy, right?
It's a great way of putting it. There's a
Yeah,
lot.
there's a lot. But the thing that's really funny about it is that when you talk to people who are like just actually out there in the world trying to make this stuff work, they're kind of like, yeah, I guess there's a lot, but I don't actually have any tools there's not that much that I use or that I get a lot of value from. Um, and so just trying to like figure out what the gap is there. And one of the things I noticed is that like in this world of models where your data is continuously evolving and you need to retrain your models, and and your models are operating on these messy distributions, and so it's very, very hard to be certain about like the model's predictive performance. What is actually needed in order to make that work? And I think when you think about the life cycle of a machine learning model, from training it to testing it to deploying it, monitoring it, collecting data that's going through that, labeling a subset of that data, and then retraining your model on the data that you label. The like one piece that is like basically the way that I think companies should think about making decisions about moving models through that life cycle is by having a robust understanding of how well the model is performing at each of those stages, right? So when you're deciding whether to promote a model to production, it's kind of this testing question that we were talking about, right? Like, how well is my model performing across all of my metrics, slices, and data sets that I care about? And then is that performance? Am I confident that their performance is actually better? And then when you deploy a model, since you can never really be totally confident about offline evaluation, making sure that you're able to run A/B tests and run models in shadow mode and get some like live evaluation of the models before they start eating all of your production traffic. And then for monitoring, it's kind of the same question, right? Like you want to know how well, like given this new data coming in, how well should I expect my model to be performing on that data? Like, is it, does everything look good, or is there like some degradation in performance, or some like something unexpected where I just don't know how well it's performing? That's kind of the monitoring question. For what data I should recollect, you should, most people just randomly subsample data, which makes a lot of sense. But it turns out that like in these long tail distributions, randomly subsampling data is really inefficient, and you can subsample data all you want, but you're never actually going to get the data about the edge cases that you care about. So deciding what data to recollect is also a performance evaluation question, right? Like you want to collect data where the approximate performance of your model is low or maybe uncertain. Labeling is the same thing, right? And then ultimately, like closing the loop when you want to decide whether to retrain your model or not. Really, in a perfect world, the way that you'd make that decision is just an ROI decision, right? It's like, okay, is the expected gain from retraining my model greater than the cost of retraining the model? And it's like, it's really hard to approximate that. But at least if you can have an understanding of how much your model's performance has degraded in production, then you might be able to like start to get at proxies for that question. And so that was kind of like the core insight, is that at each of the stages along the life cycle of a model, the kind of the operational lift is, there's a lot of like pipeline stuff and sort of like data piping that needs to happen. But the core decision that humans need to make should be informed by the question of like, okay, do I have a good understanding of how well my model is performing at this stage so that I can continue to move it along?
So it's really analyzing in each stage of this process. You're analyzing it, and it's a human that's analyzing it and saying yes or no, like we can move it forward.
Doesn't have to be a human. I think over time, a lot of these things can start to be automated. But I think, right now I'm sort of, I think my near term, like medium term mindset on like how machine learning systems are going to get created is that it's still going to be, there's still going to be humans involved, but those humans are going to be involved at are going to be made a lot more efficient by tools, and the surface area of what they need to do is going to be reduced to looking at data and looking at model performance to a large extent. And then over time, like some of these steps will start to, our methods will get better and the tools will get better, and we'll start to be able to automate some of these steps. But I think it's going to be a long time before you really remove humans from the loop from most machine learning systems.
Great point. So I'm wondering, there's I want to get into the tooling aspect a little bit more and see what your vision is on how the tools do this. But before we get there, I think it's probably worth looking at this idea that came up last week in the reading group that we have. Oh, I didn't even mention in the announcements, we have a reading group now. Knew I forgot something. So there's a reading group in the community. And one of the things that came up was this idea that there are so many tools, like you said, right? There's the big landscape that we see, and there's hundreds of tools. And then you mentioned how when you talk to somebody, they say, yeah, but I don't really use any of them. I'm still using the basic stuff and I'm able to do what I need to do for the most part. And so that's what I'm a little bit, I guess the question that came up was, is there a market for this? Right? Is this actually something that people are going to start using? Because last week, this is why for me, it was a little bit like, oh, wait a minute. We talked to Daniel, who has their company Regis Banks on, or Regions Bank, sorry, on nothing that is like a specific MLOps tool, yet they are productionizing machine learning. So is it because the market is still so new, or is it because there's not enough people that are productionizing machine learning right now? I'd love to get your thoughts on how you see that.
Yeah, it's a good question. I mean, in some ways, I'm not really the right person to ask it because I'm not trying to sell a machine learning tool right now. We're building a tool, but we're not out in the market selling it yet. But I think my like short answer to that is that I think the market is I think what a lot of these companies are betting on is the future of the market, right? And so I think what like if you're going to start a company in this space, the thing that you need to believe is that machine learning. So starting from first principles, right? Like how big an impact is machine learning going to have on industry, right? Like on the companies that adopt software like this. For me, I think that like that impact is going to be absolutely massive, right? I think it like the long tail of machine learning use cases, right? Machine learning kind of becoming part of every product and service more or less that companies create, much in the same way that software is part of every product and service that companies create these days, is going to create an enormous amount of value, right? So that's the first principles thing. Is like, okay, how is this really going to become ubiquitous? And if you don't believe that, I probably wouldn't start a company in this space, or join one really. But if you do believe that, then the question is like, okay, how long is it going to take to get there? And then how is the market going to shake out? Like who's going to be able to actually have a long-term place in the market? And I don't think anyone actually knows the answer to that question. But I think that like one way to look at it is you can ask like what has changed that might make you think that now is a better time to do it than the previous generation of companies that had trouble making that work. And the evidence that I would point to is, well, first of all, right, like I think there's been a ton of investment in machine learning in a lot of companies, and I think a lot of that investment was sort of unscrutinized because there's so much hype, right? You could like just pay people to write papers for your company, and you got a lot of like brand value out of that. And I think you're starting to see cracks in that though. So Element AI had unsuccessful exit.
Yeah.
OpenAI is selling products now. Like it seems like kind of the era where you could just be 100% hype and that was okay is starting to wind down a little bit. And then on top of that, it's like, okay, well, maybe that's true, but like maybe that just means we're going into a machine learning winter, right? Like the hype is going to wear off and still no one's going to be getting value from this. And so but like, and the alternative is like, okay, the hype is wearing down. People are going to start caring about value from their models. And so it's going to be an AI boom, right? Because all of a sudden people are going to start to figure out like, yeah, this stuff needs to be useful. How can we make it useful? And so to understand which of those paths we're going down, the thing I would look at is like, what's preventing companies from being successful at getting value out of machine learning right now? And when I talk to folks, the things that always come up are like talent, right? It's really, really hard to hire good machine learning people. Data availability, right? Like in a lot of organizations, data is still not that easy to come by. It's kind of locked up somewhere, or they're not collecting it, or what have you. And then like organizational knowledge and buy-in, right? Like we don't know how to ship machine learning systems. Like our executives don't have realistic expectations. Our executives are not bought in.
Yeah.
So let's go through each of those one by one, right? So talent, right? Like basically every like Stanford, Berkeley, CMU, MIT undergrad who studies CS like takes at least one machine learning class now, and in many cases like a bunch of machine learning classes. The Berkeley Intro to AI class has like literally thousands of people in it when they teach it, and so I think there's like this whole generation of like computer scientists that are growing up with just this part of being part of the regular curriculum. And so I think the like next wave of even just like software engineers, much less, machine learning focused people, which there are more and more of, have a base level of understanding of these technologies that was not there 5 years ago. Right. So I think, there's still a shortage of talent, and especially there's a shortage of talent who have like made this stuff work in the real world before. But I think that problem is in the process of solving itself. We can talk about data availability, right? This is still a huge problem for a lot of organizations, but the thing I would point to that gives me hope there is look at what's happening in the data infrastructure market right now, right? You have Snowflake, you have like all of these startups like DBT that are, or Fishtown rather, that are like booming, raising money at bigger and bigger valuations. And so I think like one of the impacts of the data infrastructure explosion is going to be that like, okay, so now like we're going from a world in which like only top companies have mature like modern data infrastructure to a world in which many companies do. And so if you're a company and like you figure out the fundamentals of your data infrastructure, then like what do you actually want to do with that? I think for many of them it's going to be like, okay, well, like we're getting like the first thing is like analytics, right? Like let's make sure that we have insights that help us run our business. But then once you get mature on that, then the next question you're going to start to wonder is like, okay, can we start to use this data to automate parts of our business? And so I think a lot of the like fundamental missing infrastructure is, I won't say it's in place, but I think it's like on a good trajectory. And then for like organizational buy-in and organizational knowledge, this is still a big problem. But I think, like hopefully, communities like yours, maybe I would like to think at least a tiny bit like classes like the ones that we teach, like the information about how to do this well and like what it actually takes to build these systems is starting to be disseminated. So that's the case I would make why like now actually could be the time that like, the right time to actually start for companies to start getting value out of these systems.
Excellent answer. And I see somebody's just threw in the chat that can confirm that even the smallest university in Germany has a machine learning course now.
Yeah, so, it's ubiquitous now. I think people underestimate how much it is a standard part of the CS curriculum now. Like I think a couple of years ago it was like really rare to find machine learning people, and I think like every software engineer will have machine learning baseline knowledge in a couple of years.
I think our friend in common, Joe, was the one who brought up to me this idea that there's not going to be any difference between a software engineer and a data engineer in the future. His idea was that everyone is going to be dealing with data in some way. And it's for that reason, like, because every product is going to have data involved in some part of the lifespan. So cool. Now,
I don't totally agree with that. I think that the like specialization is still going to be important. Like, I think there will still be people who are focused on machine learning. There will still be people who are focused on data, people who are focused on like more traditional software systems, just because those three fields are each equally deep in their own ways. And so there's always going to be value in like knowing one of those things really well. But I think the baseline knowledge for sort of generalists across all those areas is also going to go up. Like machine learning people are no more software engineering now than they did in 2014. Software engineers know more machine learning, and so kind of they're sort of like the like baseline level is going up.
Yeah, I agree completely. So let's jump back into this eval store and talk a little bit about how you see the tools that are being used for an eval store. Is it a completely separate tool that's going to come out, or is it something that each one of these tools is going to integrate with? As you mentioned, the whole life cycle, and I liked how you put it in the life cycle. And I think this is from your slide. It's like you show the life cycle and you show the eval store in the middle. And so is it not something that like a specific tool could have? It's more something that needs to sit on top and have vision over the whole life cycle, if I'm not mistaken.
Yeah, I mean, I think if the way that you think about machine learning infrastructure is that like there should be a machine learning infrastructure tool that you adopt, then I think this should be a component of it. But then maybe it doesn't need to be a separate tool, right? So if in like 5 years everyone's going to use SageMaker, then maybe it's just part of SageMaker. I personally think that I think there's value in end-to-end tools for a particular type of user, but I think I don't think that that's how most companies are going to build machine learning systems. Look at the software tooling market, right? Like, there's not a lot of like companies out there using end-to-end software engineering platforms.
Yeah.
So why would machine learning be any different? Like every company has different data, different problems, different products they need to integrate with. And so I believe more in like a modular ecosystem. And I think like to me, sort of the core of the eval store is it's a tool that allows you to define these like kind of core units that you should use to evaluate models. So data sets, metrics, slices, and be able to like define those in a central place and then apply them throughout the ecosystem of the machine learning model, right? So you shouldn't we should avoid a world in which like, PMs are like helping decide what the metrics for this model are. And then the engineer forgets to update the monitoring system. And so the metric is being computed differently in the monitoring system than it was in the testing system.
Yeah.
All of a sudden things are out of date. Like the field has made that mistake before. Let's just like, let's jump right over that step in model evaluation. And let's make sure that these things are being defined consistently. And then I think the other value that a system like this would provide is like being able to execute the computation of those things. And where that becomes particularly important is in monitoring, right? Because the challenge in monitoring is that, you don't like, in general, you don't have labels for your model. If you are able to get labels, you should. And that is the best way to evaluate your production models. But in the real world, like labels are often delayed or expensive or noisy. And so you need to have some way of being able to approximate model performance without getting labels. And so that's a hard statistics problem that is, as far as I know, there's not actually like a well-established answer to it. And so that's, I think, like the other sort of core value prop of the evaluation store is that since your offline evaluation and your online evaluation are connected, you can use information about offline evaluation to better approximate the metrics that you need to compute online.
So can you talk to me a little more about how this is different than a monitoring tool? Like, why is this something like wouldn't it be possible to say a monitoring tool should do this?
Yeah, totally. I mean, I think it's I have a slide in the talk that I give that's like, wait a minute, isn't this just a machine learning monitoring system?
Yeah.
And the basic answer is like, yeah. I mean, in some ways, this is just a machine learning monitoring system, right? But I think that there's kind of a couple of differences between the way that I'm thinking about this tool and what people normally think of when they think of machine learning monitoring, right? So, let's talk about actually let's talk about like two main things, right? So one is that like I think when people think about monitoring, the picture that people have in their mind is like, you have this like train, deploy, you know, like online inference kind of cycle, and then monitoring kind of comes at the end of that, right? And so monitoring like takes data in and then uses that data to help tell you like what is the health of my machine learning system at this point in time. That's kind of like, that's, I think, the picture that many people have in their mind when they think about monitoring. The two main differences in my mind between like what I think of as an evaluation store and what people typically think of as a monitoring system are that the evaluation store also needs to be connected to offline evaluation, right? So, and the reasons for that are for consistency, like, make sure that things are being defined and computed the same way, but also for accuracy, right? I think if you look at offline performance, you're going to be able to better approximate performance online. You'll have better context for that performance. So that's one difference. Is it's not just an online thing; it's an online offline thing. And then the other big difference in my mind is that monitoring kind of implies this like one-way flow of information, right? Use the monitoring system or like the observability system as like a pane of glass into model performance. And it helps you understand like what is the health of my system at this given point in time. But in machine learning, unlike in traditional software, model like performance evaluation, and understanding that is actually critical to the model development process itself. And so what that implies is that like this system should also have hooks into the rest of your machine learning stack, and because you'll need to use that evaluation information to make decisions about training and data gathering and labeling and promoting to production and that sort of thing. So I see it fundamentally sitting in a different part of the stack than a monitoring system does. I think it's actually pretty central to everything that we're going to do when we build machine learning systems. And so the answer is like yes and no.
Well, who would be the person that is interacting with the evaluation store? Is it a data scientist, the machine learning engineer? Who is like the right person that is going to be saying, okay, I want to do this or I want to do that, like you said. And I think this is a really key point, is how we learn this lesson in software engineering, like fix it once in one place and then have it get updated in all the other places. So you don't.
Well, we've also been burned by that in machine learning in particular, right? Like this is kind of, in my mind, a big part of why feature stores are becoming popular, right? Is that like tons of like lots of teams ran into the problem where like, okay, if we have different people that are building the models then deploying them, then it's really, really easy to introduce bugs because the two teams define some feature differently, or like what feature gets updated in training and you forget to update it in production, right? And so I think to the extent that like that there will always be multiple parties involved in the development of machine learning systems, which I think in many cases there will be, then it's important to have a mechanism that forces you to standardize definitions of things like this. So yeah, but in terms of who will actually be interacting with it, I mean, it's kind of funny because all of these role definitions are still so fuzzy. I think, so when I think of machine learning engineer, the way I define that is the person who is responsible for productionizing the model. And typically that means that they're also responsible for maintaining it, but that's not always actually the case. Some companies want like analytics to maintain the models, or they want, maybe the people who develop the models to maintain them. So I kind of think of like the roles in the process of building a machine learning system, independent from like what they're called in most organizations, because that's another thing that's a mess. But I sort of think of it as like the machine learning scientist, who's the person who's training the model, the machine learning engineer, who's the person who's deploying and maintaining it. And those can often be the same person. Sometimes they're not. And then you have the platform team. The ML platform team is a thing in many organizations, like MLOps team, if you will, the PM, and then the business stakeholder, right? Like the person whose work this thing is influencing. I think the interesting thing about this is when you actually think about who needs to use the evaluation store, it's actually all of those folks, right? Because one thing that everyone who has a stake in the model really cares about is like having a say in how that model is evaluated, like how we decide whether it's good or not. And they should have transparency into how the model is doing right now. So I actually think like one of the other functions a tool like this can play is like being a sort of glue between the different stakeholders that are involved in model creation.
So then you would see it as like the hub, not only for all of these different pieces, but for all the different stakeholders, where they could
Yeah, and
log in.
I don't like to call it like the hub, because I think there could be different ways to build a system like this. When I think of how we want to build this system, it's has a lot more to do with like sort of fitting nicely into the ecosystem that already exists, rather than like trying to replace everything else that's out there.
Mm-hmm.
I think, I think this is like a interesting trend in the machine learning infrastructure world, is that like everyone is kind of like, so many people are aiming to build end-to-end tools. And that's very much not what we're trying to do. Like we want to build developer tools. Like we want to be a puzzle piece that fits into, how you build training pipelines already, and how you're deploying models already. And, if you have existing monitoring systems or existing testing systems, or like, existing like data set exploration tools, like we want this to kind of fit in with those things, and it'll replace some pieces of them. But we don't think that this should be like an end-to-end system.
Well, and then if I understand this correctly, it would be something that you could look at and get a quick overview of how everything is doing. So it gives you more vision into the whole process. And if you need to drill down on something, you can go there. It will give you an alert or something. It will show you that, hey, in this piece, or you will make the decision because you will see, oh, well, maybe if we change this, we'll get better results from the data collection. Maybe we should start doing something different here in the data collection, because you're getting more visibility into this and you're seeing how it's interacting with all of the different pieces. Is that?
Yeah, I think that's right. Yeah.
So it's like you check in. I'm trying to think of some kind of metaphor, but it's like you're checking in there. And then if you want to go and drill down deeper, you can go to each specific piece and you can try to make it better in the different pieces, the individual pieces. And it's not only you as a data scientist, or I like that term, machine learning scientist, it is you as any stakeholder that has anything to do with the product that you are shipping.
Yeah, for sure. And I think those different users will interact with the tool differently, right? I think probably, machine learning engineers are the ones who I think will spend the most time using a tool like this. But I think it is important to kind of like how, one of the sort of impacts that like DevOps observability tools had on software organizations was that they took, monitoring and ops and turned it from something that was like this sort of siloed function that operated in its own world without that much connection with the rest of the org, and turned it into like a team sport, right? Where you still have ops teams. I mean, I guess they're like DevOps teams now, but software engineers also use Datadog and like use that to check up on the systems that they're building and stuff like that. And so I think machine learning is still in one of the big challenges for a lot of companies building machine learning systems right now, is still this kind of walled garden world, right? Where like the machine learning scientists are building models, and then they're not really like the ones to productionize them because that's not their skill set. And so they have to like toss these models over a fence to some other team. And then it causes just so much pain for everyone, because the people on the other side of that fence are not machine learning experts. And so they kind of treat these models like a black box, and, and they try to productionize them that way. And then it takes months, and machine learning, the people building the models are like, why isn't my model in production yet? And the people on the other side are like, well, it's hard. And they're not really speaking the same language. They're not communicating that well. And it leads to bugs because things are translated to production the wrong way. And so I think tools that can help cross organizational silos are in general really valuable. And I think that that's one of the roles that a tool like this could play, is to help facilitate a common understanding of what it is that we're building, how we're evaluating it, and how well it's actually doing right now.
Incredible. Yeah. So last question, as we're finishing up, I asked your friend James for a question. I went and sourced one from him, and he was saying, could you tell us what are some of the technical challenges that the two companies that you mentioned in your presentation, Apple and Tesla, were facing to make their systems work?
Yeah, I mean, I haven't worked at either of those companies, so I'm probably not the right person to ask about this. I think, I really like the way that Andre Karpathy talks about some of these challenges. And I think that the data engine that they created is sort of like one of the inspirations for the work that we're doing. And the idea there is like you as a machine learning engineer, your job is to help make your model better, right? And so one of the ways that you can make your model better is by understanding like where it's not performing well, and then trying to make it better on those edge cases. And so one problem that they faced was that like as a machine learning engineer, maybe you can find an edge case, like you can like spend a bunch of time looking over the data, and then you realize like, oh, hang on a second, we're getting really, really bad performance every single time that there's a left-hand turn in the rain around sunset.
Mm-hmm.
And but then the problem that they were facing was that like, okay, well then how do you actually fix that problem as a machine learning engineer, right? So you could you could try to like synthesize some data, or you could like try to like do some feature engineering and come up with some new feature that would help with that, or you could like change the model architecture around. But their thesis, which I think is like, for at least for deep learning systems, is very much like the philosophy that most people should have, was that like the best way to improve the model is almost always going to be to go and collect more data. And so the challenge that presents is like, how do you get data that looks like this edge case? And so like maybe you actually send drivers out and you like set it up specifically so that they're encountering these edge cases that you want to be able to get more data for. That's not very scalable, and it's not always possible. And so what they came up with is the system where the engineers, the developers, can write these like arbitrary monitoring hooks, for lack of a better term. And what those hooks are like literally smaller machine learning models that are like noisy detectors of that edge case. And then they built the infrastructure that would allow them to deploy those hooks onto the vehicles. And so then when the vehicles are, when you're driving your Tesla around, right? Like when data comes in that fires one of those hooks, right? So this noisy detector says, hang on a second, this looks like, I think this edge case looks like, or this image looks like that edge case that we were trying to solve for. Then that'll get uploaded to their cloud, right? And so then, not all of those images will actually be the scene that you're trying to detect, because if you could build a perfect classifier for that issue, then you could probably solve the problem. But, if you collect 100,000 images like that, then they're going to be more likely than not to be from that type of scene. And so then when you label them, all of a sudden you've bootstrapped a data set that you can use to help solve that edge case. And so I think that's that sort of core infrastructure is something that as machine learning use cases get more and more complicated, higher and higher dimensional data, bigger and bigger models, larger training sets, is going to, many companies will need in order to continually improve their systems over time.
Excellent. Thank you so much for coming on here and explaining this. I'm really excited to see what you are building. So let us know when it's finished. And
yeah, we'll do. I mean, I'll let you know before it's finished. It's
yeah. Let us know
when
it's
pretty hard product to build. So I think it's finished is a strong word. But
you may not be able to say it, but are you going to open source it?
I can't say yet, but
I didn't think so.
But
I'd ask though.
I do. I will say that I do really like open source, and
okay.
I think it's a really good way to build infrastructure. So yeah, take that for what you will.
That is a great answer, diplomatic one, answering by not answering. So Josh, awesome man, and thank you everyone who came. I am seeing that there was questions now. I'm sorry, I was so enthralled by Josh's talk and what I wanted to ask. I didn't get to you. Forgive me, it was selfish, but that means that you can just go and reach out to him on our Slack channel, because Josh is there in our MLOps Slack.
Yeah,
Feel free.
I'm hanging out in Slack. You can also reach out to me on Twitter. I tend to eventually respond to Twitter messages.
He does tweet.
And yeah, excited to talk more about this with folks. I think, well, it's something I'm really passionate about, the broad topic of like, how do we make machine learning work in the real world? And yeah, so if you're curious to talk more about this stuff, if you like want to implement an evaluation store at your company or want to think about how to do that, I would be particularly eager to talk about that, because that's kind of like what I'm thinking about on the day-to-day these days.
Excellent. I really appreciate it. I just threw the Slack link in the chat again in case anyone did not get it the first time. And Josh, man, thank you. We'll see you all later.
Yeah, this is fun.
Bye-bye.